Good morning, sir. We're the members of Group 5 and we'll be looking at the periodic trends. The members of my group are Ricky Somwaro, Daniel Somra, Titrangeli Ruturant, myself Tanya Budu, and Sarah Day. In this presentation, we'll be looking at the formation of hydrides of the Group 6 elements, explaining the trends of the Group 7 elements, also known as halogen, and stating the special properties of the Group 8 elements. I will now hand you over to Sarah.
Okay, so the formation of hydrides from the group 6 elements. So first we'll do some general properties of group 6 elements. So oxygen all the way down to polonium are elements of group 6A. They have 6 electrons in their outermost shell. Their oxidation number is -2. They have a high value of electronegativity. Oxygen and sulfur are non-metal. Selenium and tellurium are metalloids, and polonium is a metal. Elements of group 6A, they show allotropy. Oxygen is a gas, but the other metals are solids. Generally, they have electronegative elements. So moving on to the formation of hydrides. Next slide. So hydrides are formed when the elements react with hydrogen, and all elements of group 6 form hydrides of the type that H2 react with any of the elements. For example, H2 reacting with oxygen would give us water. H2 reacting with sulfur would give us hydrogen sulfide. And the hydrogen of the hydrides of sulfide, selenium, and tellurium are prepared by the action of acid on metal sulfides, selenides, and tellurides, respectively, where H hydrogen sulfide is prepared in the laboratory with the KIP apparatus by the action of diluted sulfuric acid on iron sulfide. And below there is the equation for this. So, and water is a colorless, odorless liquid, while all the other hydrides of these elements in the group are colorless, bad smelling, and poisonous gases. All the hydrides have angular structure, which involve a sp3 hybridization of the central atom. For example, in the structure of water, they are two bond pair and two lone pair. Due to the presence of a lone pair, the bond angle in water is less than the normal tetrahedral angle, in that it is found to be 104 degrees. And as we go down the group, the bond angle in the hydride decreases. And as we move from oxygen to tellurium, the size of the central atom goes on increasing and the electronegativity goes on decreasing. The position of the bond pair of the electron shifts more and more away from the central atom, moving from water all the way to hydrogen telluride. And for example, the bond pair of oxygen to hydrogen bond is closer to oxygen than the bond pair of in a sulfur to hydrogen bond. And as a result of this, the force of repulsion between these bond pair of electron in water is more than the repulsion that is in hydrogen sulfide. So some of the trends and the characteristics of hydrides are all the hydrides are volatile. The volatility increase from water all to hydrogen sulfide, and then it decreases. Thus, the trend of volatility is water is less than hydrogen sulfide, which is less than hydrogen fluoride, which is less than hydrogen telluride. And the explanation for this is because the high bond of water molecules through the hydrogen bond, and the hydrogen bonding is not present in all the other hydrides. The intermolecular forces between hydrides, except water, they are the van der Waals forces. Another characteristic of this is the acidic characteristic. The hydrides of group 6, they are weakly in acidic character. Their acidic character increases from water to hydrogen telluride as they go down the group. Another characteristic is thermal stability. thermal stability of hydride decreases from water to hydrogen telluride. So as you go from the top of the group to the bottom of the group, water to hydrogen telluride, the thermal stability of hydride decreases. The reducing characteristics, so all hydride except water are considered to be reducing agent. The reducing power of these hydride increases from hydrogen, from water to hydrogen telluride. So that is the reducing characteristic. As you go down the group, the reducing characteristic increases. Thank you. Moving on to the next presenter.
Trends in group 7 elements. Fluorine, chlorine, bromine, and iodine belong to a family of elements called the halogen or salt-producing. All four elements are very reactive nonmetals. They are not found free in nature but exist as compounds with metals. A halide is a halogen with atom with a -1 charge, example, chlorine, bromine, and iodine. The halogens are important economically as the ingredients of plastics, pharmaceuticals, photographic chemicals, as anesthetics, and dyestuffs. They all consist of diatomic molecules X2, which are linked by a single covalent bond. They are volatile. The intermolecular van der Waals forces increases down to the group as the number of electrons in the atom increases. They are strong oxidizing agents and are able to gain one electron easily. At room temperature, fluorine is a pale green gas, chlorine is a yellow-green gas, bromine is a dark red liquid, and iodine is a shiny gray black solid. The physical properties of halogens are as follows. It can be seen that there is a regular increase in many of the properties of the halogen proceeding down from fluorine to iodine. This includes their melting point, boiling point, the radius of corresponding halide ions, and the density of the element. However, there is a regular decrease in the forced ionization energy as we go down this group. As a result, there is a regular increase in the ability to form high oxidation states and a decrease in the oxidizing strength of the halogen from fluorine to iodine. I will now hand you over.
Good morning, sir. I'll be talking about the group 8 element. The group 8A of the periodic table of elements contain noble gases that have high ionization energies and low electron affinities. The noble gases are a group of elements wearing crowns, sitting on the thrones and feasting on the finest foods. Despite their name, the noble gases aren't actually nobility, but they are a group of gases located on the far right of the periodic table. Valence electrons, valency, atomic size, ionization energy, metallic character, electron positivity, electron negativity, and the reactivity are the characteristics of groups. Group 8 elements of the periodic table are the noble gases, or we can call it the inert gases. They are such of like helium, neon, argon, krypton, xenon, and radon. Some might want to ask that how did the name noble gases come about? The name comes from the fact that these elements are virtually unreactive towards other elements or compounds. Some basic characteristics of them: they are inert gases located on the right side of the periodic table. They have a full set of valence electrons, so that's why they are stable. They are colorless, odorless, and tasteless. They have low boiling point and melting point. They can be found in small amounts in the Earth's crust and the Earth's atmosphere. Thank you. That's all for me.
Thank you. This is the end of our presentation, and here's a list of our references.